Hello everyone. Today we will discuss about gravity. Scientists around the world have been expecting a theory that will explain gravity at the fundamental level. And they name the theory as quantum gravity. But surprisingly, this theory has been revealed not as quantum gravity, but as the singular numerical relativity. The reason is simple, because by studying relativity based on numbers, we can explain gravity. And gravity is not the only issue in physics. Gravity is just one of the issues in physics. Therefore, the singular numerical relativity is very well armed with tools to solve all those issues in physics. So today, especially, I decided that we will talk about gravity because I want you to understand that the discovery of the singular numerical relativity is the solution to everything today. Throughout history, people have been wondering about the objects falling. Even ourselves, human beings, we fall down all the times. You make a small mistake, you have an accident. All of that, it's because of gravity. Nobody could really explain how exactly gravity works before the 16th century. Because in the 16th century, one person in the name of Galileo, a mathematician from Italy, decided to really understand and calculate the speed of the falling objects. And in the course of his researches, he was able to create something like this. You are going to see. We call a realm. This is a sliding board, and on this sliding board, Galileo will let a ball roll. Then he will calculate the distance and the time it takes to roll. So he arranged in a way that the circumference of the ball will be 1 unit of distance. And the very first duration the ball will roll on the first tour will be the unit of time. Therefore, when he rolled the ball once, the distance was only 1. So, and this is the time. Time is 1. And this time is called Galileo time, unit of time. Then he tried now for 2 units of time. in 2 units of time, he observed that the ball traveled 4 times. In 3 units of time, the ball traveled 9 times. As you see here, these numbers which appear here have a very good relationship. That if 1 here gives 1, this 1 may be 1 squared. 2 gives 4, 4 equals 2 squared. 3 gives 9, means 3 squared. Therefore, Galileo concluded clearly that the distance a body travels during the free fall is proportional to the squared of time. So this is very clear, very simple. And because of this, gravity was formulated by, let's see what the singular numerical relativity says about this. When I discovered the structure of numbers 3 years ago, I never studied any mathematics of Galileo. I knew the story of falling bodies at the same rate. I knew about the observation of space with a telescope, but no single equation came to me. So I never knew anything about this experiment. However, you will see here, I have already explained before in the structure of numbers that when a number travels, like this one, we know that numbers are vibrating springs, and they vibrate, they have to pass through levels. At level 1, for a number, for any number, it will take 3 values. Level 2, it will take 5 values. Level 3, 7. Level 4, 9. Level 5, 11. Level 6, 13, etc. So this relationship is real. And we were able to demonstrate that when a number travels, and it will occupy space. Therefore, we have what we call the information area. And that information area can be calculated by simply having the level number plus 1 squared. We found that. Therefore, we found that if the level is 0, at level 0, this is level 0, number 4 occupies 1 squared area of information zone. Then when it moves to the next level, it will occupy 3 more values here, or areas. These 3 areas will bound together with this, the first area, then they make 4. So 1 gives us 4, which is 2 squared. 2 will give us 3 squared. 3 will give us 4 squared. 4 will give us 5 squared. And it says clearly there that we have to get the level number plus 1 squared. So we take time, we take the level number plus 1 and squared. So what is more important here is this one. How much the number of values are increasing. Because even in Galileo, we will see that the distance that the body travels is different from an area to another. From time to time, there will be different speed, different number of rolling for the ball. So, this is the key we want to verify. Because this is the area that links everything to Galileo experiment and what it is here. For you to understand it, we show you just this graph here. We have number 4, this one. Actually, this is the same as this, but now we are presenting it in form of a real squared area. So you see, we start with 1 unit. Then, when the number will move to the next, it will occupy 3 more units, and this make 4, 2 squared. These 3 units here, or we call 3 values here, make what we call the squared arrow. The squared arrow of 1. Now, if we want to know the next squared arrow, which is in green here, this squared arrow will have 5 values, because it is the second level, as you see here, the second level, 5 values. Then it makes 3 squared. We go to the next, become 4 squared. Next, 5 squared. So this is the arrow of the square. The squared arrow of a number can be calculated as this. So the increase here can be calculated as this. So if you want to know how many values you find on that level, then you have to get the level number times 2 plus 1. The level number times 2 plus 1. So now you see there is a difference between Galileo interpretation and our interpretation here. Galileo interpretation is that 1 gives you 1 squared. 2 gives you 2 squared. 3 squared. But here we say 1 gives us 1 plus 1 squared. 2 gives us 2 plus 1 squared. 3 plus 1 squared. 4 plus 1 squared. 11 gives us 11 plus 1 squared. So let's ask ourselves, what went wrong? What went wrong? Let's go back to the board of Galileo. On this board, you see very well. During the first bit of time, the ball traveled only once. During the second bit of time, it traveled 3 times. The third bit of time, it traveled 5 times. So, you see that it is increasing. Therefore, if we want to know how far we can travel, for example, a body can travel, we cannot just base that on just that time. Because my time can start here, can start here, can start anywhere along this line of time. So what will I do? Because this body here is accelerating, the speed is increasing at every step. So how to do the calculations? This is the way we should think. If we are calculating this, we have to think this way, that what is my initial time and what is my ending time? How long I will travel? That's where we should start thinking of. We must think about in terms of that. Because, as you see here, this one, where it came from, it traveled 1, this one in purple. It traveled once. But what is 1? 1 is 0 plus 1. And this one is 0 plus 1. So meaning, it means this one here is equal 0 plus 0 plus 1. 2 times 0 plus 1. And 0 is my starting time. My departure time. And here, it goes that my departure time is 1. Then I have to move to the next bit of time. How far I will travel, I just get 1 plus 2 and gives me 3 in the bit. Here it is 2 plus 3 gives us 5. And if you compare, we see that 2 times 2, the 2 times 2 plus 1. And this becomes the relationship. We say that if my time increases by 1, the distance I will travel will be 2 times the initial time plus 1. Then if I want to know the whole, I have to take everything that I have traveled before. So if, for example, I cut here, then I can connect this one if what time I have traveled before. We can get all these portions added. And this portion, according to Galileo, this portion is the time squared. So you will see that we will have an equation that exists in algebra. T squared plus 2t plus 1. So what is important in all of this for Galileo's interpretation to be right is to consider this constant. It is a constant. Because at least we see the pattern. When we cut the first portion, the same thing we get in the second portion, in the third portion. So meaning that becomes our true formula. Not just this simple conclusion of yes, it's 1 squared, 2 squared, 3 squared. How did you get it? How did you get it? Therefore, the singular numerical relativity emphasizes that Galileo experiment is 100% correct. The only thing, the interpretation was the problem. Although the results look the same. That's why it has worked. So you don't need to panic. No, physicists, don't not panic, because it has worked and it's true. When you observe, even myself, in order to come up with these conclusions, it took me time to think, because I will become ridiculous. So I really thought very hard, because the results look exactly the same. Of course, when you go from 0 to any destination there, that Galileo thing works. It works perfectly. If you go from 0 to n. But the problem with it, that it has made our life miserable. Therefore, in physics, when people try to apply these formulas based on Galileo's observation, it brings problem. It brings infinites, because he missed the arrow of time. The arrow of time. What is important is not how far I will travel if my time is this. No. What is important, if I start here on this line, on my path, then how far I will travel after a certain time, even. That's what is important. Because you will not always go from the 0 point. You can be here. And what is the advantage of this way of thinking? That it allows us to quantify the information in the universe. We can make bits of information, what you call quantum bits. The quantum bits work in this way. The bits of information in space work based on this. And even we will be able to trace the whole DNA of the universe. We can also map the whole information of the universe. I have done it, so do not go and try, because it exists already. I have done it. So by simply interpreting things the way I'm doing here, by thinking in terms of my time, the arrow of time, then everything will be solved. Therefore, should we talk about quantum gravity? What is quantum gravity? There is only gravity. Because you see Galileo's and this one. Is there any difference? It is the same. The numbers are the same. The numbers are the same. Everything is the same. So the pattern is the same. So what is the problem? It is there. This is natural. That's why you can understand from here why things fall at the same rate. Anyway, there is a deeper explanation of all of this I'm talking about. Even these formulas here, you see, these are just a hint I'm giving to you. So if we want to go into the real formulas of this one, I will take you there. Therefore, let's not try alone, because it will take too much time to do it alone. It took me a lot of time to think about these things. I didn't come to the open like this just by enthusiasm. No. Even for me to really bring this one to life as you see it here, it took me months. So I had to really scrutinize, verify over and over before I will say anything before the world. So please, let's think in terms of a collective work. All the scientists will come together to now work on this mathematics. I am inviting you. Please understand what I'm saying. If you understand what I'm saying, you will get out of all this struggle about quantum gravity, because I tell you openly, quantum gravity is a wrong theory. It doesn't exist. There is only gravity. Gravity only. There are not two kinds of gravities. I think I'm very clear, and I'm saying it loudly because I'm certain of what I'm saying. I have a whole theory which will blow up your mind, because based on this you can explain the holographic principle. You can explain so many other things that Einstein was concerned about. So let's take it easy. I know that it is shocking news that you are receiving today, but take it easy. Do not take it personal, because mathematics are from nature. I didn't do anything to go and create this. It was revealed by nature. And now we are solving the problem. The problem has been there. We had infinites in our equations. Now we have to kick out all infinites. Infinite doesn't exist. There is no such thing like infinite in mathematics. If you had mathematics that gave you infinites before, they are wrong mathematics. Wrong. There's no infinite. So I would like to call the attention of everyone, and let's join me. Let's make our first move by coming together and discussing about all these things. I have a lot to reveal. Thank you very much.